Hello everyone, welcome to Digital Learning DCE. Myself Dr. Yamini J, Assistant Professor of Mathematics, Government First Grade College. In this session, we are going to discuss about some specific form of particular integrals type 4 for linear equation with constant coefficient in Differential Equation 2 BSc 4th Semester Mathematics. A general linear differential equation with a constant coefficient of order n is of the form a0 d to the power n y by dx to the power n plus a1 d to the power n minus 1 y by d to the power x n minus 1 plus a2 d to the power n minus 2 y by dx to the power n minus 2 plus etc. plus a n y is equal to f of x, where a0, a1, etc. an are constant and f of x is a function of x. Here we consider the operator capital D is d by dx. So dy is equal to dy by dx, d square y is equal to d square y by dx square and so on. So from the equation 1, we know how to write f of d into y is equal to f of x. So with that, we are going to simplify the problem with a specific form of f of x is equal to e to the power ax into w. Here f of x is equal to e to the power ax into w, where w is a function of x. So let b be any function of x, then d of e to the power ax into w is equal to e to the power ax into dw plus a into e to the power ax into w is equal to e to the power ax into d plus a into w. So we are using the product rule for differentiating these two functions. Again we have to differentiate with respect to x. So we'll get d square into e to the power ax into w is equal to e to the power ax into d of d plus a into w plus d of e to the power ax into d plus a into w. So if you multiply the terms, we'll get e to the power ax into d square plus ad into w plus a into e to the power ax into dw plus aw. Now we are taking e to the power ax as a common. So d square w plus 2a dw plus e square w. So that we can write it as e to the power ax into d plus a whole square into w. Similarly, we can write d cube of e to the power ax into w is e to the power ax into d plus a whole cube into w and so on. Therefore, f of d into e to the power ax w is equal to e to the power ax into f of d plus a into w. Let f of d plus a into w is equal to v, hence w is equal to 1 by f of d plus a into v. Now the equation 1 becomes f of d into e to the power ax by 1 by f of d plus a into v is equal to e to the power ax into f of d plus a into 1 over f of d plus a into v. That implies f of d into e to the power ax into 1 over f of d plus a into v is equal to e to the power ax into v. Operating there with 1 by f of d on both the side, we have e to the power ax by into 1 over f of d plus a into v is equal to e to the power ax into v by f of d. Therefore, e to the power ax into v by f of d is equal to e to the power ax into 1 by f of d plus a into v. So working rule for this type problem is, first step is find the complementary function for our complementary function of homogeneous part of the differential equation, d square y by dx square plus a1 dy by dx plus a2y is equal to f of x by taking f of x is equal to 0. Here we are considered second order. Similarly, we can find out for third order as well as fourth order and for the nth order also. So next we are going to find out particular integral for f of x is equal to e to the power ax into w. Now the third step is general solution as y is equal to cf plus pi. So the first example is solve d square minus 4d plus 13 into y is equal to e to the power 2x into cos 3x. So first we have to go for complementary function as usual. So first we are going to take f of d from the given equation. So from the given equation f of d is d square minus 4d plus 13. So then auxiliary equation is m square minus 4m plus 13 is equal to 0. So here the factorization is difficult directly. That's why we are going for formula method. So m is equal to minus b plus or minus root under b square minus 4ac divided by 2a. So from the equation here a value is 1, b value is minus 4, c is 13. So if you substitute these three values in the formula, we get m is equal to 2 plus or minus 3i. So we got the complex root here with alpha is equal to 2 and beta is equal to 3. Therefore, complementary function is e to the power alpha x into a cos beta x plus b sin beta x. So we got a complementary function is equal to e to the power 2x into a cos 3x plus b sin 3x. So after finding complementary function, now we are going to find out particular integral for e to the power 2x into cos 3x. Now the particular integral is equal to 1 by f of d into f of x. See here f of d is d square minus 4d plus 13 into e to the power 2x into cos 3x. See here the f of x is the combination of exponential and trigonometry. Exponential function and trigonometry function is there, means always we have to first simplify exponential, then we have to go for remaining function, whatever it is, trigonometry function or polynomial equation. So now first we have to simplify with e to the power 2x. So replace d by d plus a. So f of d is has to write as f of d plus a now. So now e to the power ax, we have e to the power 2x. So a is 2. So replace d by d plus 2 in the denominator. So if you are replacing that exponential form, simplification is over. So we are bringing it into the front. So e to the power 2x by into 1 over d plus 2 whole square minus 4 into d plus 2 plus 13. That means we are substituting in the place of d plus a. That is d plus 2 because here a is 2. Now if you expand that and simplify, we'll get particular integral is equal to e to the power 2x into 1 over d square plus 9 into cos 3x. Now we have to simplify with cos 3ax form. So cos ax form means we know we have to replace d square by minus a square. That is minus a square is minus 9 here. So d square is equal to minus 9. We have to substitute in the denominator now. So e to the power 2x into 1 by minus 9 plus 9 of into cos 3x we have. So we got the denominator value is 0. That is pi of minus a square is equal to 0. If we got like this, we know 1 by d square plus a square cos 3x is equal to x by 2a into sin 3x. So if you apply that formula here, we'll get pi is equal to e to the power 2x into x by 2 into a is 3. That's why e2 into 3 sin 3x. So we got pi is equal to e to the power 2x into x by 6 into sin 3x. Therefore, the general solution y is equal to cf plus pi. That is e to the power 2x into a cos 3x plus b sin 3x plus e to the power 2x into x by 6 and sin 3x. Now the next example is solve d square minus 60 plus 9 into y is equal to e to the power 3x into x square plus 7x plus 5. So here in the place of f of x we have exponential as well as polynomial equation. Now we will go for complementary function first. So from the given equation f of d is d square minus 60 plus 9. So auxiliary equation is m square minus 6m plus 9 is equal to 0. So if you are going for the factorization, we will get m minus 3 whole square is equal to 0. Then m is equal to 3 comma 3. So both the values are real and distinct. That's why complementary function is c1 plus c2 into x into e to the power 3x. Now for going for the particular integral, pi is equal to 1 by d square minus 60 plus 9 into e to the power 3x into x square plus 7x plus 5. So first here also we have to simplify e to the power ax. So in the place of d we have to replace d plus a. So here a is 3, e to the power 3x is there. So a is 3. So replace d by d is equal to d plus 3 in the denominator. So we will get e to the power 3x into 1 over d plus 3 whole square minus 6 into d plus 3 plus 9. into x square plus 7x plus 5. So now we have to expand with a plus b whole square formula in the denominator and simplify. We'll get e to the power 3x into 1 over d square plus 6d plus 9 minus 60 minus 18 plus 9 into x square plus 7x plus 5. So here 60 will cancel. Yeah, then minus 18 plus 18 also cancel. We have only 1 by d square. So e to the power 3x into 1 by d square into x square plus 7x plus 5. Now we in the denominator we have d square. So we are going to split it as 1 into d, 1 by d into 1 by d. So the d is in the denominator. We know we have to integrate the polynomial equation. So first time we are going for the integration, means x square become x cube by 3 plus 7 into x, x integration is x square by 2. Then 5 into x we got. Again we have to integrate these terms. We will get x cube integration is x to the power 4 by 4. Already 3 is there in the denominator. So we have x to the power 4 by 12 plus 7 into x square integration is x cube by 3. So 3 into 2 is 6 in the denominator plus 5 into x square by 2. If you simplify this, we'll get e to the power 3x into 1 by 12 into x to the power 4 plus 7 by 6 into x cube plus 5 by 2 into x square. So we are going for the general solution now. Y is equal to CF plus PI. So we'll get C1 plus C2x into e to the power 3x plus e to the power 3x into 1 by 12 x to the power 4 plus 7 by 6 x cube plus 5 by 2 x square. The next problem is d square plus 3d plus 2 into y is equal to e to the power 2x into sin x. So now from the given equation f of d is d square plus 3d plus 2. So auxiliary equation is m square plus 3m plus 2 is equal to 0. So using the factorization we can write m plus 1 into m plus 2 is equal to 0. So m is equal to minus 1 and minus 2. So here both the values are real but it is distinct. That's why the complementary function is c1 into e to the power m1x plus c2 into e to the power m2x. m1 is minus 1 and m2 is minus 2. So cf is equal to c1 into e to the power minus x plus c2 into e to the power minus 2x. Now we are going for particular integral. Now pi is equal to 1 by d square plus 3d plus 2, that is f of d, into e to the power 2x into sin x. Here we have combination of in the place of f of x we have combination of e to the power 2x into sin x, means combination of exponential and trigonometry. Here also we have to simplify for first exponential function only. So exponential function simplification means in the place of d we have to substitute d plus 2, that is d plus a. A is here 2. So replace d by d plus 2 in the denominator. We got e to the power 2x into 1 over d plus 2 whole square plus 3 into d plus 2 plus 2 into sin x. So if you simplify the denominator, we will get e to the power 2x into 1 over d square plus 7d plus 12 into sin x. So it is sin ax type we have to use. So sin ax type means we have to replace d square by minus a square. So here what is a? Sin ax. In the place of sin ax we have sin x. So a is 1. So replace d square by minus 1 square. So if you substitute d square is equal to minus 1, we will get in the denominator 70 plus 11. So we have pi is equal to now e to the power 2x into 1 over 70 plus 11 into sin x. So sin x, sin ax or cos ax form means we have to try to get d square term in the denominator. So here we have only 70 plus 11. So we have to get d square term. That's why we are going for conjugate multiplication. So in the denominator we have 70 plus 11. So conjugate of that is 70 minus 11. So multiply and divide by 70 minus 11 we are doing in this step. So now e to the power 2x into 70 minus 11 by 49 d square minus 121. So a plus b into a minus b form is there. If we are going for that, a square minus b square form we will get into sin x. So if you again we have to substitute d square is minus 1 by replacing d square is equal to minus e square is equal to minus 1. So the denominator become minus 170. The numerator is 70 minus 11. Now e to the power 2x by minus 170. Sin x has to multiply with 70 as well as 11. So 70 into sin x minus 11 into sin x. So now 70 into sin x means we have to differentiate sin x with respect to x once. So what we'll get? 70 of sin x is 7 cos x minus 11 sin x. Therefore, pi is equal to e to the power 2x by minus 170 into 7 cos x minus 11 sin x. Therefore, the general solution y is equal to CF plus pi is equal to C1 e to the power minus x plus C2 into e to the power minus 2x minus e to the power 2x by 170 into 7 cos x minus 11 sin x. Then the next problem is solve d cube y by dx cube plus y is equal to 5 into e to the power x into x square. See, now we are going for complementary function first. The given equation is d cube plus 1 into y is equal to 5 into e to the power x into x square. Here f of d is equal to d cube plus 1. Then auxiliary equation is m square plus 1 is equal to 0. Now using the synthetic division only we can simplify and get the root. For m cube plus 1 is equal to 0. So the synthetic division means we know the first row value has to coefficient of m cube, m square and m and constant value should be there. So here m cube term is there, m square is not there, m is not there. That's why we are taking m square coefficient is 0 and m coefficient is 0. So we got first row value is 1, 0, 0, 1. So we are trying with minus 1. In the first row we are taking coefficient of m cube, m square, m and constant. In the second row, first entry should be always 0. So if you are vertically adding these two means 1 plus 0 is 1. Then cross multiplication with minus 1 will get minus 1. That we have to write it in the second row, second element. So again we are going for the vertically addition. So we are getting minus 1 plus 0 is minus 1. So multiply with minus 1. Cross multiplication we are doing here. So we are getting 1. That has to be write it in the third element of second row. Again we have to go for vertical addition. We will get 1. Same procedure we have to follow here. Cross multiplication we will get minus 1. The last element is 1 and minus 1. So we are getting 0. So minus 1 is the one of the root for this equation. Now with that we are writing factor that m square minus m plus 1 is equal to 0. That is the 1 minus 1, 1 is there. That values are coefficient of m square minus 1 with and constant is 1. So we have m square minus 1 plus 1 is equal to 0. Now we have factorization of this equation directly is difficult. That's why we are going for formula. So in the formula we are substituting a is equal to 1, b is equal to minus 1 and c is equal to 1. So our formula is m is equal to minus b plus r minus root under b square minus 4ac by 2a. So substitute these values in this formula. We'll get 1 by 2 plus r minus I into root 3 by 2. Therefore, complementary function is c1 into e to the power minus x and complex root alpha is 1 by 2, beta is root 3 by 2. That's why e to the power x by 2 into a cos root 3 by 2x plus b sin root 3 by 2x. So now pi is equal to 1 by d cube plus 1 5 into e to the power x into x square. Again we have combination of exponential and polynomial function. So always we have to go with exponential first. So in the place of e to the power ax we have e to the power x. That means a is 1. So replace d by d plus 1 in the denominator. So 5 into e to the power x into 1 over d plus 1 whole cube plus 1 into x square. So replace d by d plus 1. So simplify this with a plus b whole cube formula. We'll get in the denominator d cube plus 3d square plus 3d plus 1. So if you simplify that, we'll get pi is equal to 5 into e to the power x into 1 over d cube plus 3d square plus 3d plus 2 into x square. So polynomial functions are there. We have to use binomial expansion. Binomial expansion means we have to get 1 plus x term or 1 minus x term. That is that form we have to get. So to get that form, we are taking 2 as a common value in the denominator. So we'll get 5 into e to the power x 1 over 2 into 1 plus d cube plus 3d square plus 3d divided by 2 into x square. So now that constant 2 will come along with 5. So we have 5 by 2 into e to the power x. Then the denominator value comes to the numerator, means 1 plus x form become 1 plus x whole to the power minus 1. So here x in the place of x we have d cube plus 3d square plus 3d divided by 2. So we know the binomial expansion of 1 plus x whole to the power minus 1 is equal to 1 minus x plus x square minus x cube plus etc. So we are using that expansion for this x value. So what we are getting in the next step, 5 by 2 into e to the power x into 1 minus d cube plus 3d square plus 3d divided by 2. That is, in the place of x we are substituting all these values, plus x square by 4 minus etc. into x square. So here in the algebraic function, that is polynomial function, is only x square we have. So if we can differentiate maximum 2 times, third time onwards the x square becomes 0. So that's why we have to consider in this d square term, d term and constant term. So first one will be like that only. From the second term we have to take only d square term and d term. No need to take d cube, because d cube become 0. 3 times if you differentiate x square, it becomes 0. That's why we are not going to consider. Then the third term we have to consider d square. If you are going for d cube plus 3d square plus 3d whole square, will get 6 d to the power 6 term, d to the power 4 term and d to the power 2 term. So we have to consider only 3d square by 4. 3d square by 4 terms, 3d square 3d whole square by 4 terms we have to consider. So first with 1 x square is multiplying, means we will get x square. Then next minus 3 by 2 into d square into x square. If d square into x square means we have to differentiate x square 2 times. If you differentiate first time, we will get 2x. If you are going for second time, we will get 2. That's why it is minus 3 by 2 into 2. Then next term is minus 3 by 2 into d of x square. d of x square means only one time we have to differentiate x square. That's why we got 2x. Then from the third term we have to consider 3d whole square by 4. 3d whole square means it become 9d square by 4. So 9 by 4 into d square of x square. D square of x square means we have to differentiate x square 2 times. So we'll get only 2 for that. So if you simplify all this value, we'll get 5 by 2 into e to the power x into x square minus 3x plus 3 by 2. So if you take 5 by 4 e to the power x into 2x square minus 6x plus 3, we'll get after taking the LCM. Now particular integral is 5 by 4 e to the power x into 2x square minus 6x plus 3 we have. So now the general solution is y is equal to CF plus PI, that is equal to C1 e to the power minus x plus e to the power x by 2 into a cos root 3 by 2x plus b sin root 3 by 2x plus 5 by 4 e to the power x into 2x square minus 6x plus 3. Then next problem is solve d square y by dx square minus 2 into dy by dx plus y is equal to x into e to the power x into sin x. First we are going for CF. So from the given equation, fd is equal to f of d is equal to d square minus 2d plus 1. So we can write it as d minus 1 whole square. So we can go for auxiliary equation is m minus 1 whole square. So m minus 1 whole square means m value is 1 and 1. So both the values are real and repeated. That's why complementary function is c1 plus c2 into x into e to the power x. Now we are taking pi is equal to 1 by f of d. What is our f of d in this problem? D minus 1 whole square into x into e to the power x into sin x. See here, three terms are there. X into e to the power x into sin x. So here x into e to the power x into sin x is there, means what we have to do as usual, first we have to simplify with exponential function. In the place of e to the power ax, we have e to the power x. That means a value is 1. So replace d by d plus 1 in the denominator. So what we'll get, e to the power x into 1 over d plus 1 minus 1 whole square into x into sin x. Now we are getting e to the power x into 1 over d square x into sin x. That is, in the denominator we have d square. So we are going to take 1 by d into 1 by d. That is 1 by d into 1 by d into x into sin x. That means we have to integrate x into sin x 2 times. So first time we are going for the integration. So e to the power x into 1 by d is there. So first time if you integrate, integration by parts only we have to do here. So x into minus cos x minus 1 into minus sin x will get. So use the integration by parts, we'll get x into sin x as x into minus cos x minus 1 into minus sin x. If you simplify that, we'll get minus x into cos x plus sin x. Now we are going for second time integration. So in the second time integration, for first term we have to use integration by parts. Then second term we can integrate directly. So minus we can keep it along with x. So x into minus x into cos x. For this we are using integration by parts, means we'll get minus x into sin x minus of minus 1 into minus cos x. Then sin x different integration is minus cos x. If you simplify all this value, we'll get pi is equal to e to the power x into minus x sin x minus cos x minus cos x. So we have cos term is 2. So we are combining that too. So we'll get e to the power x into x minus x sin x minus 2 cos x. So we can take minus as a common value. So we are getting pi is equal to minus e to the power x into x sin x plus 2 cos x. Therefore, the general solution is y is equal to c1 plus c2x into e to the power x minus x into x sin x plus 2 cos x. So thank you for watching this video.